Okay, so we're going to be graphing lines using the slope-intercept form. That is the purpose of this video, to show you what I think is probably the best way for graphing lines. First of all, what is the slope-intercept form of a line? The slope-intercept form of a line looks like this: y equals mx plus b. Okay. Now, what do these numbers mean? Well, y and x remain there as variables because you need to have the two variables in order for this to be a linear equation. But the reason they call it the slope-intercept form is because the slope and the y-intercept are given to you once you have an equation in this form. The slope is actually m, and the y-intercept is the point 0, b. So slope is m, so slope is right over here next to the x, and the y-intercept is going to be given right over here. This is very important information. So these two pieces of information allow us to graph, I should say accurately too, allow us to accurately graph any line. Okay? So let me go over the steps for how to graph a line using slope-intercept form. So step one. Now step one is going to be to put in that form because not always do we have the lines already in that form. So step one, put your line in slope intercept form. Remember, that just means to solve for y. Okay, so put your line in that form first. Step two, you're going to plot the y-intercept. So always start by putting that dot there. Step three, use the slope. Don't forget that's the rise over the run to find your next point. I should say another 1 or 2 points. Now, how do you use the slope to do that? Well, here's what you have to remember. Because the top number of your slope is your rise, this tells you whether you go up or down. Up is if it's positive, down is if it's negative. The run tells you whether you go right or left. Right if it's positive, and left if it's negative. Step 4, draw your line and label all points. So that's it. It's a 4-step process, but it's really nice. You have the slope of the line, you have the y-intercept, and you have as many points on the line as you want. Okay? All right, let's try some examples. For all these examples, we're going to graph the line using the slope intercept form. So number 1, y equals negative 2/3 x plus 4. Negative 2/3 x plus 4. Remember our equation. Our equation is y equals mx plus b. So this is already in the right form. So let's write down what we know. We know that the slope is negative 2/3. And the y-intercept is 0, 4. So let's go ahead and start to draw our picture. First, we graph the point 0, 4. So 1, 2, 3, 4. There's 0, 4. Now, notice we have negative 2/3. So negative 2/3, I'm just going to go ahead and assume that the top number is negative. You could also make the bottom number negative. Just remember not to make both negative, because if you have negative 2 over negative 3, that actually just means 2/3, which would be positive. Okay, so this means that we go down 2, and this means that we go right 3. So down 2 spaces, 1, 2, 3, so we're right here. We can go do it again. Down 2 spaces, 1, 2, 3. So actually we have this line. And that's our equation. Let me go ahead and label here. This is 0, 4. This one is 3, 2. And this one is 6, 0. Always make sure that you label your points. And that's it. That's our line. Let me do another one. Y equals 3x minus 1. Notice this one is already in slope-intercept also. We're starting off a bit simple, but we are going to do some trickier ones. So in this one, m is equal to 3, and the y-intercept is equal to 0, negative 1. So start by drawing your y-intercept. 0, negative 1 would be right here. Now, if the slope is 3, that's the same as 3 over 1. You always want to have a number on the bottom as well. So this means that you're going to go up 3, and this means that you're going to go to the right 1. So we go up 1, 2, 3, to the right 1, so we're right here. So last step, well actually why don't we do another one? Sometimes if you don't want to go up 3 and over 1 again, since that gets us kind of high right now, near our numbers up there, what we can do is we can actually say down 3, left 1. Because isn't negative 3 over negative 1 the same as 3 over 1? They're both equal to 3. This is still just 3, right? So notice if I go down 3 to the left 1, I'm right over here. Which just gives me a more convenient point to work with right now. But we're still on the line. Let's go ahead and label what we have. This point right here is 1, 2. This point is 0, negative 1. And this point is what? We went down 3. So this is negative 1, negative 4. And that's it. Not too bad, right? Let's try another one. What about the line y equals x? Now notice that it doesn't quite look like we have it in slope-intercept form, but we do, because this is really the same as 1x plus 0, since there's nothing after that. So our slope is 1. Let me go ahead and put it over 1. And the y-intercept is 0, 0. Actually, a very easy line to draw. First of all, we're at 0, 0. And then we go up 1, right? Because this means up 1, and this means to the right 1. So up 1 to the right 1, we're right over here. And let's do it one more time. We're right over here. So this is 0, 0. This is 1, 1. This is 2, 2. And that's it. Alright, so let's actually practice some tougher ones where we have to put it in slope-intercept first. Okay, not too much worse, but they do require more work. So this is going to be number 4. I want us to graph 5x plus 2y equals 8. 5x plus 2y equals 8. First thing I'm going to do is put in slope-intercept form, so we have to solve for y. So I'm going to do that by moving the 5x over. First, I get 2y equals negative 5x plus 8. And then I divide both sides by 2. Remember now, you actually can divide this by 2 and this by 2. It's the same thing. We get y equals negative 5 halves x plus 4. So the slope is negative 5 over 2, and the y-intercept is 0, 4. Go ahead and draw our little picture here. First we do 0, 4. There's 0, 4. Then we go down 5 to the right 2. Right? This negative means down 5, and this positive means to the right 2. So down 5 to the right 2. Let's do another one. Down 5 to the right 2. So there is our line. Let's go ahead and label these points. This is 0, 4. This one right here is 2, negative 1. And this one is 1, 2, 3, 4, 5, 6. So 4, negative 6. Let's do one more example. How about 3x equals 3y plus 3? Interesting example, because in this problem we have the x is kind of by itself, not quite, and the y is over there. So I'm going to start by actually moving the 3 over, since I want to isolate the y. I end up with 3x minus 3 equals 3y, and divide by 3. Remember, I divide everything by 3. I get y equals x minus 1. Be very careful with your signs. The number one mistake I see students make is they actually mess up the signs when they divide by a negative or whatever it is. So, there's actually an invisible 1 here. I'm going to go ahead and write that in. So the slope is 1, and the y-intercept is 0, negative 1. Let's do our picture here. First, you always do 0, negative 1. You always do the y-intercept. The slope being 1 is the same as 1 over 1, so just like the last one, we go up 1 over 1. And again, up 1 over 1. So this would be 0, negative 1. This would be 1, 0. This one would be 2, 1. Let me do one more tricky example. What if we have something like this? Y equals 4. Notice that there is no x in this problem. If this ever happens, this is actually the same as 0x plus 4. So the slope is 0. Now, if we want to put a bottom here, you can put any bottom you want, so I'll just put a 1. 0 divided by 1 is 0, so that does make sense. The y-intercept is 0, 4. So if we draw our picture here, first we have 0, 4. And now, if this is saying that we go up 0, and then this is saying that we go right 1, that means we're just going to go to the right 1. Sorry, right here. That's what I meant to do. If we do it again, we're just going to be right here, and so on. So actually, this is a horizontal line. But we could have done that anyway, because we know that when we're missing an x and we just have y equals 4, that this is a horizontal line. I just wanted to show you guys that the slope-intercept form does agree with it. Last case, actually, I do want to talk about really quickly what happens if you have the y's missing. So let's say x equals 1. This one you cannot put in slope-intercept form. It's the only time that you can't. And the reason is there are no y's. So you can't solve for y if there's no y's. So if ever this happens, just do it the old-fashioned way. Plot your points. No matter what you have for y, x is always 1. So we have 1, 0, 1, 1, 1, 2. So this is a vertical line. Remember, we have a vertical line whenever we're missing the y's. So this is a vertical line. Let me go ahead and label this as 1, 2, 1, 1, and 1, 0. And that is it. I hope that graphing lines is a little less mysterious, and I'll see you guys next time.